Chapter 3, Section 3, Proving Lines Parallel. So here are a few theorems. Now these are all converses, meaning we had the corresponding angles theorem in the last section. Now we've taken the converse. So instead of P implies Q, now we're looking at Q implies P. And it is also a true statement. If two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. So let's say that they don't tell you that the lines are parallel, but it is given that 2 is congruent to 6. That means that L is parallel to M, which you can see here. Now this works for all of these theorems. So alternate interior angles, same side interior, and alternate exterior. So copy down the following theorems, the examples, and the conclusion that you end up with. Because whether it be corresponding angles that are given, alternate interior, same side interior, which are supplementary, or alternate exterior, if the angles are congruent, or if same side interior supplementary, that means that the lines are parallel. So even if it's not a given statement, if these angles exist, congruent, add up to 180, and congruent, then the lines cut by the transversal are parallel. So let's try a proof. This is a proof of the converse of the alternate interior angles theorem. Well, let's come up with a plan of action first. We're working with angles 4 and 2 and angle 6 from the given picture. In order to prove that L is parallel to M, since it's the converse of the alternate interior angles theorem, we can't use interior angles. So we're actually going to work our way around this with corresponding angles because that comes before the alternate interior angles theorem. So we're going to have our statement and reason columns. The first statement is going to be the given. So angle 4 is congruent to angle 6, and that's given. Then we're going to say that angle 2 and angle 6 are corresponding angles because two lines cut by a transversal form corresponding angles. And our reason is that two lines, we don't know that they're parallel, but two lines cut by a transversal form corresponding angles. Well, we also know that angle 2 and angle 4 are vertical angles because intersecting lines form vertical angles. Which means that angle 2 is congruent to angle 4 because vertical angles are congruent. Well, since angle 4 is congruent to angle 6 and angle 2 is congruent to angle 4, they're both congruent to angle 4, so they must be congruent to each other. Angle 2 must be congruent to angle 6 by the transitive property of congruency. And like we said before, since angle 2 and angle 6 are corresponding angles, And since those corresponding angles are congruent, that means that L is parallel to M, because if corresponding angles are congruent, the two lines cut by the transversal are parallel. Are parallel to each other. Symbol for parallel to each other, and that would be the end of our proof. Now there's a few things that we could have done differently here. We could have switched 2 to the 6th step, right in between 5 and 6 here, so that it was closer to the bottom. But as long as it's somewhere in your proof, since they're corresponding angles, and down here since they're congruent, these lines are parallel. It would also be acceptable if you combine steps 3 and 4. So you just put angle 2 is congruent to angle 4, but then your reasoning would have to be intersecting lines form vertical angles which are congruent. So you'd have to include this whole thing for the reason. Few different things, a few minor changes, but make sure you have every detail. So if you have to separate it into 2 steps, do that to make sure you don't forget anything. Here we have another proof, so let's write our statement and reason column again. We're going to start off with our given. Take a minute to see if you can come up with a plan of action for this proof. Even if you don't write it completely on your own, take a minute to pause the video and see if you can come up with an idea for what we can possibly do. So one option would be to somehow get 3 and 5 alternate interior angles to be congruent. If we can prove that alternate interior angles are congruent, then we can prove that the lines are parallel. Since this is actually a proof, if you want to add it in, this is a proof of Theorem 3.7. So it's a proof of alternate exterior angles. So we're not going to just simply state that angle 1 and 7 are exterior angles, because we're trying to prove the converse of the exterior angle theorem. So instead, let's look at alternate interior angles, because that does come before the exterior angles theorem. Well, if we can somehow prove that 3 is congruent to 5, then we can prove that L is parallel to M. We can also do corresponding angles. If we can prove that 3 is congruent to 7, or that 1 is congruent to 5, we can also then prove that L is parallel to M. Finally, we can use same side interior to show that they're supplementary, and that would prove that L is parallel to M. I'm going to go the route in this proof of proving that angle 3 is congruent to angle 7, so corresponding angles are congruent. So my next step is going to be to state that, and I'm going to combine steps here, angle 1 is congruent to angle 3 because, and this everything needs to be included here, intersecting lines form vertical angles which are congruent. If you feel like you're not going to remember that, then separate it into 2 steps. Separate it into saying angle 1 and angle 3 are vertical angles, then saying that they're congruent. But if you can remember all of this, then you can combine the 2 steps. Since angle 1 is congruent to angle 7 and angle 1 is congruent to angle 3, we can say that angle 3 is congruent to angle 7 by the transitive property of congruency. Since angle 3 is congruent to angle 7, and we know that angle 3 and angle 7 our corresponding angles because two lines cut by a transversal form corresponding angles. We can now say that line L is parallel to line M because if corresponding angles are congruent, the two lines cut by the transversal are parallel. And we abbreviate parallel here. And that would be the end of our proof. But there are multiple different ways that you can do this. When we're proving a theorem, so like here we're proving 3.7, we don't want to use what the theorem states. So when we're proving alternate exterior, we don't want to use alternate exterior. In any other case, if you're not proving a theorem, you could have just used alternate exterior angles here. Finally, we have an algebraic example. What is the value of x for which A is parallel to B? Well, if A is parallel to B, that means that these two angles would be same side interior. And we know that when two lines are parallel, the same side interior angles have to add up to 180 degrees. So 2x plus 9 plus 111 would have to equal 180 degrees in order for A to be parallel to B. So now we solve. We combine like terms. 9 plus 111 is 120. Subtract 120 from both sides. 2x equals 60. Divide by 2 on both sides. X equals 30. Which means the value of x in order for A to be parallel to B would have to be 30. Which means we know the measure of this angle is 111. The measure of this angle would be 2 times 30 plus 9, which would be 69 degrees. All the question's looking for is the x value. But we know if they're supplementary, this should be 69 degrees, so the answer does make sense.